Hello, everyone, and thank you for being here today. I'm excited to share a creative inquiry-based science learning sequence I've developed for our Year 1 students. My name is Azra Morgan, and it's a great honour to be able to share this with you all. This sequence focuses on the Australian Curriculum Descriptor, AC9S1U02, being describe daily and seasonal changes in the environment and explore how these changes affect everyday life. My six learning stations that I developed engage students through digital tools, hands-on experiences, cultural knowledge, and scientific thinking. This approach promotes deep engagement and aligns with evidence-based learning practices and learning through theorists. Today, I'll walk you through the rationale behind this design and show how it supports some high quality science learning in the earlier years. Let's begin by exploring some of the strengths and limitations of this approach. One of the key strengths is it allows for students to actively participate in their own learning. Each station gives students a chance to explore science through different modes, whether it's observing the weather online, building dioramas, or listening to a verbal First Nations story. This multimodal engagement caters to diverse learning styles and fosters student agency, which is supported by constructivist theories of learning, especially Vygotsky's concept of learning through social interactions and cultural tools. I have structured the stations using the 5 E's instructional model: engage, explore, explain, elaborate, and then evaluate. This model, developed by Bybee in 1997, helps scaffold student inquiry and promotes a deep understanding of scientific concepts. For example, in our stations, students engage with real-time weather data, explore seasonal sorting games, explain their thinking through collaborative discussions, elaborate by constructing seasonal dioramas, and evaluate the changes by reflecting on some nature photography that they're going to do. However, there are some limitations that we have to consider. One issue is access and fluency with technology. Not all students may be confident using digital tools and iPads and laptops and so on, and they must be well managed to avoid distractions. Additionally, while the station format promotes independency, it still requires a strong teacher facilitation to guide and extend thinking. These limitations can be mitigated through some scaffolding, peer support, and explicit teaching of the digital literacies. Research by Hattie in 2009 emphasizes the importance of teacher clarity and feedback, which will be vital in this setting. Next, I want to highlight some of the pedagogical tools used in this learning sequence. First, I've integrated ICT meaningfully. Students will use weather websites and apps like the My Weather app to collect and interact with real-world data. They will take some photos using tablets and then also use printers to print stuff out and personalize their own personal diorama scene. This use of technology supports the TPAC framework, which highlights the intersection of technology, pedagogical, and concept knowledge. Visual tools, such as the pre-mentioned dioramas and some actual weather charts, will support learning through dual coding theory, which shows that students remember information better when it is presented in both verbal and visual formats. The inclusion of some First Nations seasonal story links directly to the cross-curriculum priority of Aboriginal and Torres Strait Islander histories and cultures. This aligns with the curriculum's expectation for culturally responsive teaching and supports students in seeing science as a relevant thing in their own context, in their own lives. And I think it should really bring out some excitement for them. This learning approach is deeply rooted in small group learning. Students work in pairs or small groups to complete each station. For example, they might collaboratively work on recording observations, sorting seasonal items, or constructing a diorama. Small group learning supports social constructivism, where knowledge is co-constructed through shared experiences and dialogue. According to Gillies, structured group work enhances verbal reasoning, engagement, and student achievement. Students learn from each other, question each other's thinking, and explain their reasoning in a safe and supportive environment. These interactions help build a metacognitive awareness and scientific language use, both of which are crucial in early science education. The flexible group design also allows for differentiation, supporting inclusive and equitable learning practices, covering all your learners in the classroom. A unique strength of this unit is its incorporation of First Nations knowledge. In our station number 2, students are going to listen to stories shared by a visiting elder. These stories present a different way of understanding seasons, one that is local, observational, and deeply connected to land, culture, and sustainability. This learning experience helps students appreciate that scientific knowledge can come from many, many different sources. According to Campbell and Chiluk, incorporating Indigenous knowledge helps build cultural responsiveness and supports children in developing respect for country and culture. This approach also acknowledges that First Nations peoples were the first scientists, which detailed seasonal calendars based on long-term ecological observations. It aligns also with the science of a human endeavour strand. It helps students connect personal, cultural, and scientific knowledge into one. In summary, this science learning sequence is a rich, multi-layered approach to teaching seasonal change. It supports the development of scientific thinking, social collaboration, and cultural awareness and digital literacy. It aligns with the key theorists, including constructivism, Vygotsky's social cultural theory, TPAC, and dual coding. It incorporates the 5 E's inquiry model and reflects the expectation of the Australian curriculum, including the general capabilities and the cross-curriculum priorities. Most importantly, it puts the children at the centre of the learning, inviting them to observe, question, build, and connect with each other and the world around them through science. Thank you for watching. Thank you for being here. Thank you for listening. I hope that this inspires you to see the creative possibilities within our science curriculum. And I welcome any feedback and any ideas for how we can expand this. Thank you.